Alrighty, we've been going through the PowerPoint for Chapter 4 for making decisions. Decisions being if statements and comparisons and things like that. We talked about nested if statements. I believe we've talked about if, else, if. Is that correct? I'm going to make eye contact with you. Have we done if, else, if, else, if? Yeah, okay. And, or, and not. We're going to take a moment to talk a little bit more about that. Did we have a question on the last exam that showed some zeros and ones or trues and false and asked whether this was a and logic table or an or not?
No, I think so, didn't we? I think we did.
Okay, so we pretty much already have the idea that if you do A or if A and B, and then you have A and B in the result, if A is false and B is false, is the result true or false? It's false. If A is false and B is true, since it's an and, they both have to be true. So that doesn't meet the requirement. So that's still a false. If you have a true and a false there, well, you still have one false involved in here. So that's a false. And the only time it's true is there. And you could replace F's with zeros and T's with ones, and it would be the same thing. So that's the and truth table. Or, very similar. If A or B. A, B, result. False, 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 true, true, false, true, true. So, what is A or B? What is the result if they're both false?
False.
It's false. What about false and true? Excuse me, false or true. If A was false but B is true, does that make a true or false?
True.
Makes it true because the or means one or the other has to be true. That means that if this one's true and this one's false, that it's a true. And if this one's true and that one's a true, of course it's a true. You can kind of see an interesting little pattern. That's the only case where an and is true. That's the only case where an or is false. Helps you memorize it. Okay. We've done the conditional operator too. We covered all this stuff except we did this, correct? Where if x is less than 0, we do that, else we do that. That's called the conditional operator. Does that look familiar?
Yeah, because if it's true, it triggers the first one.
Exactly.
Okay, yeah, that was on.
Right. So if you have an expression that looks like this, A is equal to, is B greater than 0? Question mark. If that is the case, then A becomes yes. But if B is not greater than 0, then A becomes no. So if B is 10, what's A going to equal? Well, is 10 greater than 0?
Yeah, it does.
So that means that A equals yes. If B is negative 10, well, is negative 10 greater than 0? Nope, so it's going to equal no. What I'm wondering is how we did all of that and not do the switch statement. Is it just that we stopped at that point?
We covered the switch statement last time.
Right, we covered it last time, but I mean,
Oh, we covered that.
ands and ors and conditional we had already done by the last exam. but we hadn't done switch by the exam, so I'm just puzzling myself over why we skipped the switch statement. But we've used it now. Let's go ahead and put it into our notes. But we could do something like this: CIN into A, and then you do switch A, and you have several cases. If A is a 0, you do something. Cout 0. What happens if I leave off the break, like I just did? And then, if it's a 1, I'm going to print out a 1. If it's a 2, that's the last one I'm going to do. Then do a print out a 2. And if it's a none of the above, it prints out, I don't know. Alrighty, so I left off the break statements. So if I send in a 1, what is it going to do? It's going to print 1, and then it's going to fall through and print 2, and then it's going to fall through and print I don't know. So that's bad. We need to add breaks. Unless fall through is really what you want, then it's very, very, very rarely what you want. And like I said last time, if it is, you better put a comment right there inside that case saying why there's no break. There we go. So that's correctly implemented. If you leave the break off, you will get fall through, where the code goes from one case to the next without stopping. In the above example, without breaks, if A equaled 0, it would print 0, 1, 2, I don't know. Beginning of the class. However, we haven't really lectured on it until today. But loops tend to operate based on a variable, a control variable, a loop variable. And why do I say that? Well, one thing we were doing is just having a while true loop and then a break statement, but normally you do something like this. While, t is less than 10, do something, whatever that something supposed to is. Cout t, whatever. And then you have to increase t, because if you never change this counter, it'll never break, it'll never leave the loop. It'll just keep printing out that same number over and over and over again. So what you typically do is tack on a t++ there. That's called incrementing t. You have to declare your counter variable before you get into it, and you have to initialize it. So now we've declared it. We can initialize it. T is equal to 0. This is going to print 0 from 9. So let's label our steps. This declares it. This initializes it. This is our comparison. And this is our increment. Without the incrementer, it would run forever printing out zeros over and over and over. So the while statement is like an if statement. It's just a safeguards this block of code, and it stays in this block of code until t is no longer less than 10. So that would print out 0 through 9. If you want to reuse that loop counter, you have to reinitialize it. You can't redeclare it. Once you've declared a variable, that's pretty much it. But say we wanted another loop that would print the numbers 0 to 100. We have to do this. We have to set t equal to 0 again. And then while t, if I wanted to include 100, what do I make it? I don't make it just less than 100, because that would stop it at 99. What do I need to do to get it to include 100? I could make it less than or equal to 100. I would consider that the ideal solution, or you could just make it less than 101. Either way would get it, allow it to go up to 100. So that is C out. And by the way, apparently there's a missing assignment where I told y'all I want you to do some homework involving counting, and then I forgot to actually upload or make a Dropbox for it. I think that's the case. So we'll make another one just like it for today. Anyways, okay, there we go. This has the same sequence of steps, except we skipped declaring it because it was declared up here. The above code prints 0 to 100. Do you see why we had to reset t equal to 0 there? What would have happened if that wasn't there? What does t equal by the time this loop exits? If we set a breakpoint and we watched t all the way through here, then by the time we got to here, if this was commented out, guess what t is at this point? If we did C out, t is like that, guess what it would print? I mean, we can even find out. Let's stick this code into Visual Studio. When you type it in, you could leave off the comments. I don't have my boilerplate yet, so I'm going to go grab it. In order to make it all fit on one page, I'm going to condense the code a little bit just by moving the braces up to the same line. And I'll show you what I mean. I'm going to put that brace there. Maybe I'll delete that blank line. All right, hopefully that's good enough. Well, since I made it print out 100 stinking numbers, have to scroll up quite a ways to see it. But there it is. Compare this to this. Even if you don't have all of the code entered, I want you to have this part done. And then I want you to run it and compare it to what you see in the output. Why is t equal to 10 here when it gets to that statement right there? All right, we've got guys in here who programmed for 30 years. I know you guys know.
Because that's what proves it false for the while loop.
Right, because this thing said as long as t is less than 10, stay in there. But when t finally hits 10, t is no longer less than 10. It bails out of the while loop, and so t is now equal to 10. So as soon as it went into this while loop, nothing changed it because I have this t is equal to 0 line commented out. That's why when it started counting up to 100, it just picked up right where we started. It goes 10 all the way down to 100. So does it make sense now why we might have a c equals 0 or a t is equal to 0 or whatever before a while loop? I'm going to make eye contact with one of the people who asked that. Does it make sense now? Okay, good. All right. A for loop is just an improved while loop. Otherwise, they're exactly the same. What do I mean by that? It just condenses everything. It puts a declaration and an initializer. It puts a comparison and it puts an increment all in one line. So I'm going to scroll down here and we're going to make a for loop. What do I want this one to do? Count from 10 to 20. Good enough. With a for loop. So for. I could reuse that t variable, but I feel like making a brand new one. Int x is equal to 0. Nope, I don't want to start it at 0. I want to start it at 10. Int x is equal to 0. X is less than, nope, not less than. I want it to include the number 20. So x is less than or equal to 20. X plus plus. And then C out x followed by an ENDL. If you don't want it to count by ones, you can make it count by tens or by -1. This update here can be anything you want it to be. So, count from 100 to 200 by 20s. For int x is equal to 100, because that's our starting point. X is less than or equal to 200, because that's our ending point. X plus equals 20. We want 20 added on to x each time. C out x ENDL. Now, why have we been using for loops a lot recently? Because we were playing with arrays. So let's make an array. I think I forgot to add # include string up at the top, so I'm not going to make an array of strings. An array of ints. Good old ints. Int pi parenthesis square brace in square braces equal to, and let's give it some numbers, 3, 1, 4, 1, 5, 9. This is one of the two ways that you create arrays. This is known as using an initializer list. Now let's write a loop that'll print it out. We've seen two different kinds of for loops that print out arrays. One is just a simple for loop with an index counter, and then the other is a for each loop, which they give a special name and I do not recall it. So we're going to use the index counter. For int I is equal to 0, I like I for index. I is less than, well, I don't know the length of that array, honestly. I better calculate the length of that array. Or I better have declared it up here. I'm just going to calculate it. Int length is equal to size of the pi array divided by the size of an int. Excuse me, size of int. And now I can use that length right here. See out my array pi at index position I. And then I'm going to print out a character return an ENDL at the very end because I skipped the ENDL there. That way it'll put them all, in one line. I need to check something. So we know what plus plus does. It's the same as saying plus equals 1. Have we discussed what happens if you put the plus plus in front of a variable rather than behind the variable? They actually mean two different things, although you would think that they don't. The end result is the same. If you do this, x plus, or let's do this. X is equal to 10. Y is equal to X plus plus. If the plus plus follows the variable, then it's the last thing that happens. X is equal to 10, Z is equal to plus plus X. If the XX precedes the variable, it's the first thing that happens. Here it's the last thing that happens. So X gets copied into Y before it gets incremented. So by the time we're done here, Y is equal to 10, and then X is equal to 11. Why is X 11? Because it just got increased by 1. Y is equal to 10. Y is equal to 10, or why? Because X got copied into Y before it got incremented. Here, the plus plus is the first thing that happens because it precedes the X. So X becomes 11, and then it gets copied into Z. So at this point, Z equals 11, and X is equal to 11. Usually, it doesn't matter. You know, if you're just doing something like this, for X is equal to 0, X is less than 10, X plus plus, that's going to be the same as this. There's going to be no material change in how those work. It's only when you're assigning values or when you're doing something else other than just the increment. If there's more than just the increment going on, that's when you need to care about whether you want that increment to happen the first thing in the statement, as in that case, or the last thing in that statement. So, if you have A is equal to 20, B is equal to plus plus A, tell me what B equals at this point. The plus plus is in front of the A. What does that mean? That it happens first or last? It happens first. So what does A equal after the plus plus? It added 1 to it, so what does A become?
21.
It becomes 21, and then B becomes 21. So C is equal to 30. D is equal to C plus plus. Always kind of gives me pause when I type that. So the plus plus, does it precede or does it follow the variable? Obviously it follows it. Does that mean that it's the first thing or the last thing that happens in this statement? It's the last thing. So C actually gets copied into D before C gets increased. So D is equal to 30. And then C is equal to 31 after that statement. Hope that makes sense. Plus plus precede the variable. It's the first thing that happens when the expression is evaluated. Plus plus follows the variable. It's the last thing that happens. Why is that important? Why am I spending 10 minutes talking about it? Because what if you had something that looked like this? Void, print val, it takes an I, and it just prints it out. Not a real complex operation. And then say you have this down here in main. Int A is equal to 0. Print val A plus plus. What is it going to print? Is it going to print a 0 or is it going to print a 1? You have to think it through. The plus plus follows it. That means the plus plus is the last thing that happens. It happens even after this function is called. So since that's the last thing that happens, what gets passed in? What does I equal? It equals 0, so it prints out a 0. Now if we do this, int b is equal to 0, print val plus plus b. The plus plus is the very first thing that happens. So B gets incremented to 1 even before it calls print val. So since this is equal to 1, that gets copied into here and it prints a 1. Why would you bother sticking A++ right in there instead of print val A and then follow that with A++? Well, some programmers like to cram as much into a single line of code as possible. So they're incrementing variables and they're passing those variables into functions or as part of expressions and the same thing. I don't show you all that, but you're going to run into code where people do things like that. So that's why I harped on it. Having harped on it enough, we're going to go on. Minus minus is called decrement. Plus plus is called increment. If it comes in front of it, it's called prefix. I'm going to go modify my notes with that. So if it precedes a variable, that's called a prefix. It's the first thing that happens. If it follows the variable, the book calls it a postfix, a term we don't hear. We hear prefix a lot in the English language, but we hardly ever hear the word postfix. It's the last thing that happens. That slide is just showing what I was talking about. Since this happens last, it prints out 12 before incrementing it. Since it happens first here, then it increments it before it prints it out. Same thing here. Since the minus minus is prefixed, then it is calculated before it gets copied to num. Since the minus minus here is postfix, val gets copied into num before the decrement happens. While loops. We already know while loops. We can just skip all this. I hate this flowchart of it. If I was going to flowchart it, I would make it look a bit different. Not that it's a big deal. Not a big deal. The real key to remember is that whiles aren't if statements, they actually keep looping. Here's a little program. While number is less than or equal to 5, print hello and then increase number. So depending upon what number gets set to at the beginning, it's going to print hello a certain number of times. So there's a logic for it. If or while number is less than or equal to 5, print out hello, add 1 to that number. When I'm doing a flowchart, I'll actually put the word if or while in there so that you know that it's an if or a while rather than just make you figure that out based on where that line's going. How many of y'all had me for CIT1173? None of y'all? One? Yeah, you. Okay. So you got real tired of flowcharting. While is known as a pretest loop because it happens first. Number is equal to 6. Is number less than 5? Thumbs up or thumbs down. Is it less than 5? I think I see heads nodding no. Not a real resounding response. So it doesn't even go in there. It doesn't print out hello at all. Make sense? Okay. Pretest loop. Pretest means that the test happens at the very beginning. And if this condition is false, it doesn't even go in there. While is pretest. The condition is tested before the body of the loop. If the condition is false, the code in the body doesn't work, doesn't get executed. These little male symbols are interesting. There's another kind of loop called a post-test loop. For loops are also pretest, by the way. The do loop is post-test. Meaning that the body executes before the test is performed. Do, see out, goodbye. Number plus plus, while number is less than or equal to 5. So if we stick number is equal to 6 up here, how many times is it going to print goodbye? It's actually going to print it once. Why? Number is equal to 6. Okay, cool. Print goodbye. Nothing stopped it from getting in here. There wasn't any condition here to stop it from getting into the loop. So it goes ahead and prints goodbye. Then it adds one on to number. Number is now equal to 7. Is 7 less than 5? No, so it exits the loop. So that one up there didn't print anything because it was a pretest loop. And the condition was never true. The condition was always false. Here, since it's a post-test loop, it goes ahead and does it once. So your rules of thumb are generally this. 3 rules, guidelines. You know what the term iterating means. Same thing as counting. If you are iterating through a range of values, if you're counting a range of values, use a for loop just because it's the best syntax. If the body of the loop must be executed at least one time, use a do loop. If neither one of those are true, use a while loop. I tend to start people off with the while loop and then really never use the do loop, but there are times when a do loop is pretty appropriate. Some languages don't have them. Some languages only have while loops and for loops, Python being one. Watch out for infinite loops. If this condition never becomes true, it's an infinite loop. I can't think of a way to turn this one specifically into an infinite loop. Okay, while number is not equal to number. That's really stupid. But number is always equal to number. Oh, okay. So while number is equal to number, that's always true. And so it'll keep looping forever. In some of our code, I've just done this, while true. That's an infinite loop. But it's not really an infinite loop because we always provided a break statement to get out of it. This loop doesn't have a break statement, so it would just run forever. Example of an infinite loop. Int, number is equal to 1. While number is less than or equal to 5, print hello. Nothing ever changes number, so this condition never becomes false. So it would print hello until we kill the program. going to skip the idea of input validation with a while loop. That just means that you're testing it to make sure it's within an acceptable value. Like if you ask somebody's age, they better not type in a negative number. Counters. A counter is a variable that gets incremented or decremented each time the loop executes. For loops, we declare our counter, and then we go through them. X is equal to 0, x is less than 10. X is our counter because we want to count from 0 to 9. So a counter is also known as a loop control variable. If it's a while or a do loop, you have to initialize it before going into the loop. Why do I say must be initialized before entering a while or a do loop? Why did I leave off for loop? Because it's built into the for loop syntax. You know, if you do this, int x while x is less than 10, that's a syntax error. It can't do anything because it hasn't been initialized. But if we do this, for int x is equal to 0, x is less than 10, it's pretty much built in because you assume that in a for loop, the first part of it, the first clause, is going to be an initialization. But still, it has to be initialized before you enter the loop. I guess I won't bother narrowing it down to that. So we had our three parts of a loop up above. We had the declaration and the initialization. And then we had a while and a condition. And then we had some body. Then we had an update. The for loop has all of those things. For, it's got a declaration and an it. It's got a condition. And it's got an update. And then it's got a body. So specifically to make a loop that did the same thing as this one, it looks like this. For int x is equal to 0, what am I going to make the next clause? X less than 10. Why? Because that's what that is there. And then what's the third part? I'm going to stare at people until somebody gives me the answer. X plus plus. There we go. So that's why I like for loops. I never forget to put my increment in there, where I quite often do when I'm writing while loops. Do while loop. We just talked about that. The format is do the body of the loop while the expression. And you do have to put a semicolon there after the expression. It's really the only loop in which you do. If you do this, while x is less than 10, and you put a semicolon there, that breaks the code. It stops it from being a loop. It effectively is this. While x is less than 10, do nothing. And oh, by the way, I also want you to see out something later. So, putting a semicolon there breaks it. Don't put this here. Just like it breaks, don't put the semicolon here. Because it is treated like this. However, the do loop has to be different. And you do have to put a semicolon on it. So do some stuff, see out x, while x is less than 10, the semicolon is necessary, or else it won't compile. So if we go back, maybe I see why they flowcharted the other one the way they did. Here was a while loop. The expression gets activated before it does the statement. The do loop. First there's the body of the loop, and then there's the condition. We know what for loops are. It's got an initialization, a test, which is what I was calling the condition, and the update. That update could be a plus plus, it could be a minus minus, it could be a plus equals 10 if you were going to count up by tens. The reason I'm going through this quickly is we have already talked about this in more than one lecture. I just did not show you the slides for it. Strongly recommend reading these or hitting the chapter if you still have questions over while loops and for loops and do loops. So while you're going through the exam, the quizzes, which I strongly recommend doing before Monday. I mean, you can take them at any time after that, really, but it won't do you any good as test preparation. The for loop is also a pretest loop. If you do this, count is equal to 11, while count is less than or equal to 10. Is count ever less than or equal to 10? Nope. So it never prints hello. We seem fixated on printing hellos, which I guess is about as useful as always just printing out the number like I've been doing. You can mess with the syntax of the for loop and have multiple initializations. X is equal to 1, Y is equal to 1, right there. Or, if you do that, you might want to both be incrementing X and Y down here. And that's called test expression, but it's not the test expression. That's an error in their slide. That's the update expressions. You can omit the initialization whatsoever, in which case it looks like that. But if you're going to do that, you may as well make it a while loop. You can omit this part of it if you want. If something else is adding on to numbers, you can omit that, and it's becoming a pure while loop. That is absolutely a while loop. So why would you do that? Well, if you ever feel the need to do that, you can. So you can leave that off. You can leave that off. You can even leave that one off. This just means run forever. There's nothing to ever stop it. So it would run forever. Keeping a running total. We have been doing this with those loops that process the arrays. You have to declare what's known as your accumulator. And then you keep adding to the accumulator inside of your while loop or your for loop. So, say we wanted to add all the numbers between 10 and 20. We need a sum. I like making my sums doubles so that I can then calculate the average and it won't round down. Double sum is equal to 0. Now we need a counter. Somebody pick a counter name. X, C, Y. CTR. So int counter is equal to 0. Keep running, except I said I wanted it to go between 10 and 20. So int counter is equal to 10. Keep running as long as counter is less than or equal to 20. And then increment the counter and add that onto the sum. Sum plus equals the counter. That would add 10 plus 11 plus 12 plus 13 all the way out to 20. If you want to calculate the average after that, that's pretty easy, except in this case we don't know how many were processed, so I'm not going to add calculating the average. So technically, this thing is called the accumulator variable. And that's what's known as a running total. We were keeping more interesting running totals with our arrays. And we are about done. So let's go back and make another array. Int scores is equal to, and we're going to enter some scores, 100, 90, 80, 100. Let's get the length of that. Int length is equal to the size of the scores array divided by the size of what? Yeah, the size of an int. If this was a double, we'd make it a size of double. If it was a string, which wouldn't be good for accumulating, we'd make it size of a string. All right, so for int I is equal to 0, I is less than the length, I plus plus. What have I forgotten to do if I wanted to add up all the scores? I needed to declare something. What have I forgotten? Yeah, I don't have an accumulator. So double sum is equal to 0, and then for every number in the array, sum plus equals that array value, scores at position I, at index value I. Now we can calculate the average because we have the length of the array. So double average is equal to what? How do you calculate the average of something? Please tell me so we can go. We got to divide the sum by the length of the array. And then we could print those two things out. Calculating the sum and the average of an array. And y'all have already done this. I'm just mentioning it again because we hit the PowerPoint about it again. Okay, so this time I will upload the homework. Write for loops that will print 50 to 70 by ones, print 100 to 200 by tens, then declare an array called temps, as in temperatures, that has at least 6 numbers in it, and write code that will calculate and display the sum and the average of the temps array. Pretty easy. We've already done all of it here, pretty much, in today's assignment. So I will upload these as notes, and that's the homework portion of it. I don't know why I'm putting comments on this. All right. All right. Does that homework make sense? You might be able to whip through it in 10 minutes. That's my goal. Certainly is easier than the rainfall problem and stuff like that. Going back to the idea, what is a parallel array? A parallel array is what? We talked about this, right, when we had the months and the rainfalls, or the names and the scores.
Two arrays with something common.
Yeah, parallel arrays are two or more arrays of the same length with the data linked by the index values. So you could have this. String day is equal to Monday, Tuesday, Wednesday. Then you could have int rain is equal to, we had 1 inch on Monday, we had 2 inches on Tuesday, we had no rain on Wednesday. So if you were going to see out them, see out day sub 0, followed by a space, followed by the rain sub 0. followed by an ENDL, and then if you did that for 1 and 2 as well, it would show you the rainfall for each day. So, these arrays are of the same length, 3 elements in each array. Element 0 of the day array corresponds with element 0 of the rain array. So Monday we had 1 inch. Tuesday we had 2 inches. Wednesday we had 3 inches. We good on that concept?
Yeah.
All right. We're done. Any questions? I always forget to ask that because I figure y'all will be pushy in a good way. I like pushy.
So when it says see out day 0, will it? It'll just print Monday and then it'll.
Right, it'll print Monday 1, Tuesday 2, Wednesday 0.
Yeah.
That'll be the exact output you get. Alrighty. We can hang out, work on homework or whatever, or bail. I'll see y'all on Monday. If you get your.
Do you have a Dropbox for today's input?
Well, yeah, let's do that. All right, we'll make a Dropbox. My mistake. I already see people leaving.